Welcome back. In the last video, we explored what AI really is and how it is defined differently by people depending on how they see intelligence. So in case you haven't watched it, I highly recommend you do so before watching this. Link in the description below. Alright, so now let's continue from where we stopped. That is, exploring each of the four main approaches in AI and seeing how they differ. In this video, we talk about acting humanly. So the first approach we have is the acting humanly approach. The acting humanly approach in AI is all about creating machines that can simulate human behavior so closely that people can't tell the difference. It is essentially about making AI appear human-like in its actions. The goal of AI in this case is to create systems that mimic human actions. So if intelligence means acting in ways similar to humans, then an AI is considered intelligent if it can replicate human-like actions. This is the concept behind things like the Turing test. Now, what does the Turing test mean? The Turing test is simply a benchmark, that is a way of testing to see if a machine acts humanly or not. Proposed by Alan Turing in 1950, here is how it works. A human judge has a written conversation from both a machine and a human without knowing who is who and tries to determine which is which. Now, if the judge can't reliably tell which one comes from the machine or the human, it is said to have passed the Turing test. For example, a machine that can respond to questions with a mix of humor, empathy, and logic. If you ask it about a movie and it says, "I loved that one," the plot twist was mind-blowing. What did you think? You might think it's a human, right? Now, this ability for the machine to understand context and give human-like responses is part of acting humanly. So now that we've talked about Turing test, obviously for a machine to be able to pass this benchmark called the Turing test, there are some certain skills that it requires. So what are the skills required for a machine to pass the Turing test? That it needs to pass the Turing test. So what are they? Number one, we have natural language processing, or in short, NLP. NLP being the ability for a machine to understand and generate human language. For example, NLP allows a machine to interpret when a person says, "I'm feeling down today." Instead of giving a generic response, it could reply with something empathetic like, "I'm sorry to hear that. Do you want to talk about it?" This shows an understanding of emotions conveyed through language. Next up, we have knowledge representation. Knowledge representation being the ability for a machine to know how to store information about the world so it can use it effectively. For example, say you ask the machine who was the first president of the United States, it would need to retrieve this fact from a stored database of general knowledge and respond with George Washington. Knowledge representation lets the AI store and retrieve information as a human might. Next up, we have automated reasoning. Automated reasoning being the ability for a machine to make logical decisions and solve problems. For example, if you say, "If it is raining, should I take an umbrella?" the machine should be able to respond logically and reply, "Yes, taking an umbrella would keep you dry." This mimics the way a human would reason about such a situation. Finally, we have machine learning, or in short, ML. ML being the ability for a machine to learn from experience and adapt over time. For example, if the machine notices that people often say "lol" after a joke, it might learn to recognize this pattern as positive feedback and adapt by responding with more jokes in future conversations. But some researchers want AI to go beyond just passing a text-based conversation test, which is the limitations of the Turing test. So what they call the total Turing test was introduced. Now the total Turing test adds two more elements. 5, we have computer vision, or in short, CV. CV being the ability for a machine to see and interpret visual information like recognizing objects in a room. For example, if you show a machine a picture of an apple, it should be able to identify it as an apple, not as a dog or a cat or as a mango or an orange. Then we have 6, we have robotics. Robotics being the physical interaction with the real world, enabling the machine to move and manipulate objects. For example, imagine a robot in a restaurant kitchen. You ask it to pick up a cup from the counter and pour water into it. The robot will need physical abilities to reach out, grab the cup, and pour, much like a human would. This will show it can interact with the environment on a physical level. Now, these 6 disciplines compose most of what we have as AI today: natural language processing, knowledge representation, automated reasoning, machine learning, computer vision, and robotics. In essence, acting humanly in AI isn't just about words. It is about mimicking human capabilities in language, thought, vision, and movement. A machine passing the total Turing test would be able to engage in human-like conversations, recognize and interact with physical objects, and make decisions based on both visual and contextual information. To recap the 6 disciplines that compose most of AI, we have 1. Natural language processing, which is the ability for a machine to understand and generate human language. 2. Knowledge representation, which is the ability for a machine to know how to store information about the world so it can use it effectively. 3. Automated reasoning, which is the ability for a machine to make logical decisions and solve problems. 4. Machine learning, which is the ability for a machine to learn from experience and adapt over time. 5. Computer vision, which is the ability for a machine to see and interpret visual information, like recognizing objects in a room. And finally, 6. Robotics, which is the ability for a machine to physically interact with the real world, enabling the machine to move and manipulate objects. I hope with what we've covered, you have been able to understand what it means to create a machine that acts humanly. Now, in the next video, we'll continue from where we stopped, exploring the remaining 3 main approaches in AI. We'll explore particularly thinking humanly, and in other respective videos, we'll touch on thinking rationally and acting rationally. Let's explore each of these and see how they differ in the next couple of videos. See you in the next video in particular.